Now this is the shape of the profile along which the tool is going to be moved. So from here the distance is increasing up to this point, then it remains constant, and suddenly it is going to increase, and then the distance is going to remain constant. So as we discussed just now, so if the distance is gradually increasing, then we will be having a tapered surface. Then here we are having a constant distance, which means you are having a constant radius, which means it is cylindrical. Then there is sudden increase in diameter or sudden increase in radius. Then again you are having a constant diameter. So you are having some step over here. So you will be having a step diameter, and then you are having a conical part. So this is how the component is going to look like. So here you are having a step, and at the end you are having a conical part or tapered part of the workpiece. You are having a tool motion like this as shown. You are having a spindle axis. From the spindle axis it is moving along a curved path here, then it is moving straight, then it is again moving along a curved path, and again it is going to move along a straight line. So whenever you are having a curved path, then we will get something like a spherical profile. So this is how the workpiece is going to look like. So this end portion you can see here, this quarter circle, whatever portion is it, that will form a hemisphere. If you are having a half circle like that, then we can say that it will be more or like a sphere. Since it is quarter circle, as it is rotating around, you will be going to get a hemisphere. Then the small straight line portion here, that is the cylindrical portion. Then this curved surface, you can see it is a curved surface like that, it is fully all around it. Then you are having a straight line, so you are having a cylinder. So this is the way in which the profiles are generated depending on the way in which the tool is going to move. So we want the tool end point or the cutting edge to move exactly along this particular path. If even there is a small deviation, then the geometry or the dimension of the workpiece will be completely different. In order for a CNC to operate in a very accurate fashion, what we want is we want the tool to move in a very exact manner. So if we want to move the tool, we should be able to control the movement of the tool. So how do we control the movement of the tool? So the movement of the tool is controlled by using the coordinate points. So in the Cartesian system we are using x, y and z coordinates. Then you are having other coordinate system, polar coordinate system, then you are having cylindrical coordinate system. So different coordinate systems are there, but most commonly the CNC machine uses the Cartesian coordinate system, wherein you are specifying the different coordinates of the point, and depending on the coordinate points that are given, the CNC is going to create the motion of the tool with respect to the workpiece in such a way that we are going to get the required profile. So now if you want to control the movement of the tool, we know that we should have the coordinates. Now in the case of CNC, what are the coordinates that are to be defined in order to get the tool motion? So we have seen just now that different kinds of motions of the tool and the different kinds of geometries that are going to be created. So the tool is always moving in one plane. It is moving along two axes. The third axis is not there. So if you want to tell in a more simplistic fashion, we can say that if you are seeing in the conventional machine, the tool is moving at the level of the machine spindle. It is not going to move up and it is not going to move downwards. So in that particular plane only as the tool is moving, and as the tool is moving, it is going to create a profile about the axis of the spindle. So accordingly we will have a movement of the tool in one single plane, or we can say that you require two axis coordinates to define the motion of the tool. So normally we are having x-axis, y-axis and z-axis. So in order to have a plane, we require only two axes. So the lathe, whenever we say CNC lathe, it requires only two axis coordinates, that is the x coordinate and the z coordinate. So there is no need for specifying any y coordinate, because the tool is not considered to be moving in the y coordinate in the some simple CNC machines. But you are having certain advanced machines where you are having more axis motions possible for the tool, and there you may have to individually specify the different motions. So for most of the common CNC lathes, you require only two axis motions. By controlling the movement of the tool along the two axes, it is possible to generate the required profile of the workpiece. Now what are the directions of the two axes? So first one is the z axis, other one is the x axis. So z-axis is always along the axis of the machine spindle. So whatever the machine spindle is there, z-axis will be there along that particular axis. If you are moving away from the chuck, then it is a positive side. If you are moving towards the chuck, then we'll say that it is a negative direction of motion. Then what about the x-axis? So x-axis is very important to understand in the CNC lathe. So x-axis is along the radial direction. So at 0 diameter, the x coordinate also will be 0. But whatever the x coordinate is there that we are specifying, that is a diameter at that particular point. For example, if we say you are having a x-axis which is perpendicular to the z-axis, and you are having a cylindrical object. So at this particular point the diameter is at 20 millimeter. Then the x coordinate of that particular point will be 20. So x coordinate represents the diameter at a particular point. It is not the direct distance, it is the 2 times the distance. So by having an x-axis and by having a z-axis, we are specifying 2 axes. By any point you take in that particular plane, that is the x and z plane, we will be able to specify the coordinates, and by specifying the coordinates we will be able to fix the location of the end point of the tool, and by controlling the motion of the end point of the tool we are able to get the required profile on the workpiece. So x-axis and z-axis.